Today we want to actually see how we are going to practicalize what we have been learning for so many weeks now. So today is basically hands-on embedded system. We are going to practicalize the skill we have been learning for some weeks now. So what exactly are we looking forward to achieve? What is the agenda for today's class? So what will we learn? We are going to see how we are going to connect simple components, just simple components together to learn how the breadboard, that is the prototype board, how it works. And we are going to see how we are going to connect simple LED to blink it on and as well blink it off. This we are going to achieve using a simulator called Tinkercad. Tinkercad. This is a software that will help us to connect these circuits together. At the same time, we simulate it, see how it works. So let's move down to Tinkercad and see how we can achieve our aim for today. Okay. Tinkercad. Okay. So you go to your Google Chrome, you navigate to Tinkercad. The first link that came out, www.tinkercad.com, that is the first thing you will click. That will take you straight to the site of the developers. It's loading. Exactly. This is the home page. Okay, so if you don't have account with Tinkercad, you can come down here where you see an icon, the top right side corner. There you can register with Tinkercad, and it's quite very good. You have an account, whatever you are doing, whatever design you do will be saved in your account, and you can come back later at any time and continue in your project. So if you look at the left-hand side, you'll notice that I have already registered with Tinkercad. And there are so many projects or designs you can achieve. The first one is 3D design, circuit designs, code blocks, and some other lessons. But for the purpose of this course, we are going to focus mainly on circuit design. So you click the circuit button. Okay, good. That's loaded. Now, there are so many circuits there which have actually done, but since you want to look at something new for today, you click on create new circuit. Create new circuit. This will take you straight to the canvas or the window where you'll be able to design your circuit and simulate it for it to work. Loading. Okay, good. So this is the window where you'll be able to design your circuit. So Ekemini, please, I want to know if you have used Tinkercad before. Because I know last week assignment was being dropped. Have you used Tinkercad before? You can use the chat box and reply, either yes or no. I want this session to be interactive. want to know if you have actually designed a circuit using Tinkercad. Okay. So probably this will be the first time of you working with Tinkercad. Okay, if you look at this window, you notice the menu bar has different buttons. So, well, some of them are disabled now, but we are going to see them being enabled as we drop circuit down here on the canvas. If you look at this one here, this is a note tool. You can actually take your notes and label your component as you drop them down in the window. The next button is toggle note visibility. So you can, after writing your notes, you can either toggle it on or off. That is the visibility. So we are going to demonstrate how these tools can be used, each and every one of them. While this one is you choosing the color of your wire that you are going to use to connect components together. Very simple. When we start, you see how we are going to use this tool and you really enjoy it. While the next button shows wire type, you can select the type of wire. For example, if you click the button that is for wire color, you see a drop down actually showing different colors, varieties of colors that you can select from. So any color you want to use, can definitely use it to represent your wire. Most often, circuit design, we use black to represent the negative, and we use red to represent positive. And we are going to see how this can be used. Then looking at the wire type, you see different types of wires, normal wire, the hookup wire, alligator wire, and automatic. So these are the different types of wires that you may choose to use. While other buttons will be activated as we drop a component down here in the window, in our drawing window. Then if you look at the right-hand side, the top side, you will notice a button with a code. That is actually where you will write your code in order to control the circuit that you will build. Now, if you click this button right away, you will notice a note telling you no programmable component in this circuit. This is because we have not dropped any components in the drawing window. So there is no programmable components that have been dropped for the software to know what kind of program that we want to write. So as we progress, you'll see exactly how this can be utilized. Then after we have finished dropping our component, the next button, that is where you press your start simulation button. Start simulation, the process will start simulating and you see everything works as you want it to work. As long as you did your connection correctly and your program, you write it very fine. You can at the same time share what you have designed, your circuit with other people. The send to button, you can share with your work with other people, and at the same time, you can collaborate. When you click the button, takes you to this page where you can actually see your design, a picture of your design. You can download it to your system. At the same time, you can even use Autodesk to further to increase or to design your system more with Autodesk Fusion 360. You can at the same time convert it to electrical design or BRD file, or very simple, use email, share it with people, invite them with the invite button, and they will collaborate with you in this project. Very simple. Well, right away, let us see how we can work with the components that is inside Tinkercad. You'll notice the button here that says Find More Components. This component button. When you click it, we have two parts, the component part and the status part. Now, the component part has two menus. We have the basic and the basic contains, when you click the basic, it contains all the basic components individually that we can work with. So these are all the basic components we can work with here in Tinkercad. Now, if you want to see all the components that is inside Tinkercad, you click the All button. It will take you to all the components. You can see resistor, capacitor, polarized capacitor. The first capacitor is a ceramic capacitor. Well, this is a polarized capacitor, a diode, Zener diode, and so many other components that you can work with. Don't worry, the more you use this software, the more you really enjoy it. Definitely, I promise you, you really enjoy working with it. Okay, so the starter part, what if you actually want to see how circuits are being designed? Maybe you don't have basic knowledge of how circuits are being designed. You can actually use the starter part of it. If you click the basic, it will take you to a simple circuit design, like the first one, LED light up. LED light up. This is just a simple circuit design. See a battery, a resistor, and an LED here. Simple circuit design. A battery, resistor, LED. This is just to light up an LED with the help of the power source. That is the battery and the resistor limited. Just simple circuit designs. These are other ones. So with this, you can actually learn more on how to connect components together, different ways, and work with components. So what if you actually want to see how Arduino components are being connected? Maybe you don't have any knowledge, but don't worry. This is actually what we are going to work on today. So this is a breadboard with a circuit connected. For example, let's look at this one. If you want to actually see how the circuit look like, you just click. I click on the breadboard circuit here, and I drop it in the window. Can either drag and drop. Can either drag and drop, or just click it and take your mouse outward. It will get dropped in the window. Okay, so this is a simple circuit connection. Simple circuit connection. So with this, they're just showing you how you can actually link Arduino with the breadboard. Well, let me use this to explain how the breadboard works. Now, if you look closely here, okay, let me zoom in closer. Okay, good. If you look closely in this breadboard, we have rows and columns here. We have rows and columns. So this one, you see where the red and the black wire is being connected, and the red one. The two places they are being connected. So they are all joined together. That is the first two lines. You see where I drop my mouse, my cursor. All the dots are being connected together. So if you are with a physical breadboard, this is exactly how the connections are being done inside the breadboard. They are being connected together in row-wise. Same is true with the line in which the positive wire is being connected to. You see the red wire, Now that particular line, all the things, all the holes, they are being connected together row wise. Now let's come down to the column part, the other part of the breadboard. You see a number here. Let me raise it more. Okay, good. You see a numbering 1, 2, 3, 4, 5 down to 30. Okay, this is showing you each column is being numbered, each column is being numbered, each column is being numbered. Now you see a letter F, G, H, I, J. This also helps you to identify the row you are working with in each of the numbered column. Now notice how the this other part of the breadboard is being connected. See, they are connected column wise. They are connected column wise. Column 1, they are all joined together. This J, I, H, G, and F. They are all joined together column wise. Same is true with the second column, that is column 2. All the holes here, they are joined together column wise. Same is true with column 3, same is true with column 4, column 5, down to column 30. So if you want to connect something and you actually want to make use of a particular column, whatever you put in that particular column, like for example, let me say you drop your red wire here. Let me just show you a typical example. Let's assume you pick your wire. Okay, let me shift it backward. Okay, let's say you want to connect pin 9 to this particular thing here in the breadboard. You can come and select your wire type as normal. By default, it's always in normal. By default, it's always in normal. So you can come here, either come down to your Arduino, click that particular place in which you want to connect. Now you drag it down to the point in the breadboard where you want to connect it. So you see, either here, here, whenever you drop it, let's say we drop it in I, it's there. Exactly. So we have been able to connect in 9 to column 30, which is I row, column 30, I row. So this is quite simple. So that means whatever voltage is here can be transferred down to column 30, meaning that means that all these columns that is here can at the same time have the same voltage. F, G, H, I, and J, whatever pin will be transferred down here. Okay, so the same is true with the down part of the breadboard. Same is true here. If you look at the breadboard, we have seen the down parts here, row 1 down to row 30, and we have each has a column column 1 down to column 30, and each column is being numbered from A to E. A, B, C, D, E. Now, notice again, they are all joined together. And what will really help you to notice this is the line Tinkercad is using to join them together. If you look very closely, you'll notice that A, B, C, D, E, they are all joined together with a particular line. And this helps you to see that this particular column is joined together internally. This is joined together inside. So same is true with the rows. They are all joined together row wise. If you look at it, the line shows you how the connections inside the breadboard, how it is being done. So this is exactly how breadboards are being connected. So now with this knowledge, we are going to move into how we can actually utilize this in our circuit design. We want to blink an LED. So let's take this out, and we want to design the circuit from scratch. We want to design the circuit from scratch by ourselves. With that in mind, go back to the button here, the component button up here in the right-hand side corner. Okay, go to basic, click on basic, then scroll down. First, you want to drop the breadboard. Just a click on the breadboard. I can now drag it and drop it here. Good. Now, we also need an Arduino board. When you scroll down, you see Arduino Uno R3. Then we take that component, bring it down here. Okay, good. Okay, so let's move up. We need a resistor. We need a resistor. You click on that resistor component. Okay, you don't even have to drag it, just bring it out your mouse. You take the component out to the window. So there are two ways that you can drag and drop the component down here. You can either click on it and drag it with your mouse, or you just click on the component, then bring your mouse out. The component will follow you while you are dragging, while you are just holding your mouse, even without dragging it. So these are so let me drop down LED here. Good. This is an LED. So our circuits, we are good to go in our design. Let's arrange it very fine. Okay. So now we are going to make good use of these 4 components so that you will see how connections are being done. First, you have to decide which of the pin in the Arduino. Arduino here, if you look very closely, we have 2, 3, 4, 5, down to 13 digital pins. You can make use of any of the digital pins you want to use, any of the digital pins. So the first thing to do is we want to connect the LED down to the breadboard. We want to make use of this breadboard here in our connection. So I'm actually going to make use of column 30. I will make use of column 30, and if need be, another column too. So don't forget, come back. If you actually want to connect, you have to pick your wire type, the wire you want to use. But by default, the wire type is set to normal. So most of the time, you don't need to come back to wire type and pick normal, because by default, it's set to normal. Now, notice that if you click on your LED, your LED has 2 terminals here. The first one is the cathode. Let me zoom it so you can see. The first one is the cathode, and the next terminal is the anode. The cathode here is connected to the negative or to ground of Arduino, or it is being viewed as negative, the negative terminal, short and simple. While the the anode is being viewed as the positive terminal. So you have to take note of this, very, very important. the cathode is a negative terminal, while the anode is a positive terminal. Let me zoom back so that you see how the connection goes. Okay, good. Since we've selected our wire, I'm bringing this down here. That is a negative terminal. But I would like to make good use of, let me bring it down here. So this row, where you see negative row, since cathode is a negative terminal, let me bring it down here where we have the negative row. You've seen how I connected cathode down to the negative row. This is definitely where I'm going to connect. This row is where I'm going to connect my Arduino ground, or the negative terminal of my Arduino. So let me zoom back. Let me zoom back. Take this off. Let me take this off. Okay, good. Let me bring this forward. Take this off. Sorry. Let me take this off. Okay, good. Now, if you notice, look at your Arduino. You have your ground here. Your Arduino. This is a negative pin. So you just have to click it. Already your wire type is selected. So what you just have to do is to click it, take it down to this negative part. But I think that is actually very far. So what I'm going to do, let's make use of the down row here, the negative row. Yeah, I think this will be closer to the Arduino. Let's make use of this one. Now, maybe assuming you made a mistake, maybe in your drawing, assuming you made a mistake in your drawing and you want to delete a component, either wire or breadboard or Arduino, just click the component. Then notice that the delete button here is being activated. But initially, when no component is being selected, you see, the delete button is not activated. It's been disabled. You see, the delete button is being disabled here. But just in clicking here, the wire object component. So same is
Hello, everyone. I guess you can hear me loud and clear. Tutor is having little issues with his internet, and he's back now, so he will start from where he stopped. Okay, welcome, Mr. Sunday. Your internet is connected here.
Yes, sorry, someone called me while my phone is even inviting. They are still calling.
Yeah, you can share your screen. And,
okay. I hope you can see my screen.
Yeah, you can see your screen.
Okay. Okay, so now I've deleted the two wire components. Now I want to make good use of the down part of the breadboard. So what am I going to do? Good, this is the ground or the GND. You click on it. Don't forget, your wire type is already set to normal. So just click on it and bring it down here. Let me take it down here. Okay. So that actually shows that whatever I connect to this row, the negative row here, they will all be joined to the ground. That is a good part of the breadboard. Helps to make your work very, very neat and easy to work with. So now go back to the LED. Take the cathode, bring it down here. Okay. Connect it now. Okay, so this is the negative part of the cathode. So now what is left is connecting the positive part, that is the anode, down to one of the digital pins of the of Arduino board. So what we are going to do is, you can connect this directly with the resistor, but I want to make good use of this breadboard. You see how everything works. So let me bring the resistor up here. Uh, let me drop it down here. Okay, so let's pick digital pin 12. Let's pick digital pin 12. Let's pick digital pin 12. I click on it. Any of the column here you wish to use, you can drop it. Let me drop it in column 16. Here I'm dropping it in column 16 here. Now the next thing to do is to connect your resistor. Sorry, let me zoom in. Okay, good. To connect your resistor. Okay. Now I want to flip my resistor. I don't like it lying vertically this way. I want it to be lying horizontally. So what will you do? If you want to achieve that, if you click on this component, the resistor component, click on it, then come up down here to a button you see. It's called rotate button. Look at it here. Click the rotate button. It rotates the component down to the side you want it. See, the more you click, the more it rotates. Okay, so this is how I want it to lay here. So I like it this way. Let me drop it down here. Good. I want it this way. So now I'm connecting this man, the terminal 1 of the resistor, down to the same column, which is column 16, in which digital pin 12 of the Arduino board is connected to. So no, I want you to notice something here. And here, column 16, digital pin 12 is connected to column 16. And this column, you see the highlights, all the holes, they're all being connected together. So that means, though I'm dropping or I'm connecting terminal 1 of the resistor in row D, you notice that this place is letter D here. This is letter D. But for the fact that the breadboard, this particular section of the breadboard is connected column wise, whatever voltage that is being dropped here is actually what will be picked by this resistor. They are all joined together here. So with this, we can connect the other parts of the anode down here, down to the terminal 2 of the resistor. Well, my circuit may be looking messy, but this is the actually simple ways to draw this without using breadboard. Just showing you how we can use breadboard to implement this simple circuit. Very simple. Look at it once again. The ground is connected down here. Cathode of the LED is connected down to the ground. Now, digital pin 12 is connected down to column 16. And in that same column, the resistor is also connected down to that same place. Now, the question you will ask is, why do we actually need a resistor at this particular point? Because we want to illuminate or to light up this LED. Why do we need a resistor? Very good. The work of a resistor is to limit the amount of current that is flowing. Now, this Arduino digital pins supply a particular amount of current. The maximum current is 40 milliamps that can be supplied or that can be drawn from this pin. Now, this current can actually damage your LED here. As time goes, it can damage your LED. So for we to limit the amount of current that is actually flowing down to this LED, we need a resistor. So the resistor will actually limit some part of the current and just limited current or few current flow and reaches this LED, thereby making our circuit to be safe. Our LED is now safe. It will not burn and nothing will happen to it. So if we click on a particular component, for example, I just click on a resistor. Now you see a dialog box showing you the name of the resistor, name and resistance. So with this, you can actually choose what is the value of your resistance. But for the name just indicates the order of the component, which how it was being dropped. Whenever you drop a component, a name like is being given to it. But in this case, it's given to it in terms of order. The resistor was the second component that was being dropped. So that is why you are seeing it there. And the second component of the resistor, since I dropped so many resistors, so this was the second component of resistor I dropped. That is why it is named 2. I remove it and name it resistor if you wish. And name the resistor if you wish. So you say. Now let's come down here to resistance value. Now, if you click the drop down, here, you notice that we have so many different resistance values: pico ohm, nano ohm, micro ohm, milli ohm, ohm, kilo ohm, and mega ohm, giga ohm. For now, let's work with 1 kilo ohm. Well, we can actually use 220 ohm for this. We can calculate it, but since it's just a practical section, let's use 220 ohm. 220 ohm is safe, can limit the amount of current that flows through the resistor. So let's take a resistor value of 220 ohm. But remember, we can calculate this and know the exact value of resistance we should use in order to limit the current that's flowing to the LED. Okay, good. We have set the amount of resistance. We are good to go. Now, the next thing to do is for you to write a program and upload it to this Arduino board. So how will you do that? Now, go up to your code button here. Well, if you click the button here. Okay, so good. We have the block part of the circuit. We have 3 sections here, like 3 edit mode. We can either choose to write our code using block diagram, as you can see here. Everything is on block. We can write our code using this block, and we can either write our code using blocks plus text. So immediately I choose block plus text. See it here. Immediately I choose block plus text. You see the block diagram here, and you see the text. This is the raw Arduino code that will actually light up the LED and turn it off. But I think using blocks is actually for children. They're grown up. So let's use text. Let's work with text, and you write your code from the scratch. So for me, I prefer using text because this helps you to understand exactly what you are doing. Now you are about to write instruction to the microcontroller. Let me actually shift this circuit down here so that you see what we are doing. Let me shift this circuit down here. Okay, so that you see what we are doing. Good. So now this is the text. We are going to write this program. I'm going to delete everything here. Let's remove it. Because we are going to write everything from scratch so that you understand how to configure a particular pin of the Arduino, and at the same time, how to upload the code, and how you will know that it is running. Sorry, okay, we are going to change the color of the LED. No problem. Let's write the code first. Please, if you are following me, can you drop 111 on the chat box so that I will know that everyone is following? Can you drop 111 on the chat box? You're following me. That I will know that I'm carrying everyone along. Okay, good. Richard Akpabio. Thank you. So good, good. So let's continue. Now we are about to write a program. We're about to write a program. So what to do is, first, you have to configure the pin of your Arduino. Remember, we are using digital pin 12. This digital pin 12 is actually the pin we are going to use to control the LED. So it has to be configured. So the first thing to do is to write the data type or the keyword int. Int means integer. Let me see. Actually, so let me increase the font slash. Sorry, let me use slash. Good. Hope we can all see the chat box. Okay, I think it's okay now. So I've increased the font to large so that each and every one of us can see the code that we are about to write down. So the first thing to do is to configure the pin. So let me use what we call comments to help you along the way to understand what we are doing. So the first thing is pin configuration. Pin configuration, that's the first thing you have to do. Configure your pin configuration. Now, what I'm writing there is called comment. Notice the two forward slash that I'm using. This is called inline comment in programming. So this is C++ to really help you to document your programs, and along the way, you can come back at any time and understand what you have written, the instruction or the program. So now we have to configure our pin. That is pin number 12. That is the pin we are using. The pin we connect the LED to. There is what we call variable. The first thing I wrote here is int, int. That is integer. It's a data type. So what I'm actually telling the computer is that, oh, I want to store a number, and that number is an integer. Integers are whole numbers. Integers are whole numbers. 1, 2, 3, 4, 5, 6, 7, 8. They are all integers down to 1,000, 2,000, 3,000, a million, trillion. They are all integers. While what we call floating points is decimal numbers with decimal points. But int means integer. So the first thing is the first instruction, int. Now the next thing is to give the memory location a name. I'll call it LED. Since I'm working with LED, just call it LED. You just choose the variable name. Now, this variable name is actually where the name the computer will use to associate the memory location where the value 12 or the integer value will be stored. It's called variable. So now use the equal to operator and 12 with a semicolon. So what we just did here is called declaration and initialization. So we just declared an integer and we assign pin 12. The 12 there represent the pin that I'm using, this pin here, the pin 12 that I'm using for my connection. That is what it represents. So if I decide to change this pin, drag it down here, I decide to bring it down to 11. So what I will just do is come back to my come back to my code here and change this 12 to 11. Very simple. So whatever digital pin you use, you just come to your code. You can manipulate your code in order to suit with what you have done in the hard way. So after configuring the pin, the next thing to do is to write a setup function. Well, have this in mind that in Arduino, we have two main functions, the setup function and the loop function. The setup function and the loop function. So how do you write a function? Look at the screen. First, we use void. Void is a data type. Just use void setup, open and close brackets, then come down, open another braces. This is how to write a function. This is just a function and the function body. So I want you to take notice of the semicolon I use in this declaration of a variable. It's very, very important. If you are writing your code without this semicolon, there will be an error in your code. So let's continue. After writing this setup, void setup, the void actually means that this function called setup will return nothing. The function called setup will return nothing. That is void. Void means empty. Literally, in a nutshell, it means empty. But in this case, it means that this function returns nothing. Okay, so another function we need to work with for this program to work is called the loop function. So you also need the keyword void before you write the loop and your open and close parentheses. Then you put your open and close braces. Note, this parenthesis is different from this other bracket I use here. This is braces here, while this other one is parenthesis, the one that is closer to the loop and the one I use for the setup. While the braces here, the one you can see right here, this one here is actually used for function body. It's actually used for function body. Okay, we are good to go. Let's configure our pin now. Let's configure our pin. Now, in Arduino programming, you actually want to tell the program or the microcontroller that for a particular pin that you want to use it either for input or output. So you have to give it the instruction. So now we are working with pin number 11. I've actually switched from 12 to 11 to show you that it's quite easy to use any pin. So we are going to use the keyword pin mode. Pin mode. Now I'm putting a semicolon. Pin mode is a function here. Pin mode. Now notice too, pin, the mode, N is a capital letter. So you have to be careful when you are writing this program. You have to be very, very careful. If you don't actually know the right keyword to use or the function, you can go to arduino.cc, and these functions will be there. You actually see them and you can know how they are being spelled. Good. So the next thing to do is to write, let, and give argument. Well, this is another part I have to take note of. Now, a function can actually expect a parameter, or we call it argument. Now, for the setup function you see here, and the loop function, they expect nothing. You see, inside these brackets here, there is nothing within the bracket. The bracket is empty. But for the pin mode function, I'm putting two arguments, the LED and output. The LED here is telling the program that it will be replaced with pin number 11. So LED will be replaced with pin number 11, the one I use for configuring my Arduino. Output is actually telling the program or the computer that this pin number 11 that I'm using is to be configured as output. If you want the pin to be configured as input, just for you to use the keyword input. But actually, I don't want to configure it as an input, but rather I want to configure it as output. So I will use the keyword output. Very good. So with that in mind, the next step is to control the pin or toggle the pin number 11. So what to do is to use another function called digital rights. Another function called digital right. Why is it called digital right? It is because this Arduino pin, if you look at very well, you see this is D13, D12, D11, D10. All the Ds there represent digital, meaning that this is a digital pin. This is a digital pin. So we need a function that will actually be able to control those digital pins. So there is a function called digital rights. It's been recognized. Now, this function also expects you to give it an argument, a value for it to work with. And what it expects is the pin number that you are working with. I'm working with pin number 11, and in the memory, pin number 11 is known as LED. So I'll prefer using the variable LED, because if you actually want to make changes to this pin, you just come down here where you declare your pin value and change it to whatever pin you are using. Quite simple. Whereas if you were using 11 all through, maybe here you use 11, down here in digital right, you use 11, to be very stressful for you going through all the places to change the value to 11. But rather, you can just come to a particular place. That's where you declare this value and change the 11 to a particular pin that you want to work with. Okay, good to go. Let's use, after LED, digital write also expects another parameter, and that is a keyword high. Have in mind that digital expect two values, either 1 or 0, high or low, true or false, on or off. So we are using the keyword high to represent on. So that means, oh, if the instruction is now telling the microcontroller that I want you to write pin 11 high. I want you to write high. High is 5 volts. High also means 5 volts. I want you to send 5 volts to pin number 11. That is the instruction. Then for you to actually see what is happening, we are going to use a delay to delay the program. So we use the keyword delay. Now, this delay, we are going to specify, give it a value. How many seconds do you want to delay this LED, or the blinking LED that we actually created? How many seconds do you want to delay it? That is the question you should ask yourself. Now, delay works in milliseconds. Delay works in milliseconds. So me putting 1,000, I'm actually saying that I want to delay this LED or this program for 1 second, because 1,000 milliseconds is equivalent to 1 second. 1,000 milliseconds is equivalent to 1 second. So I'm delaying it for 1 second. So after 1 second, what do I want to do next? I want to turn it off. So you use the keyword, the function called digital write. At this time, I want to write to pin number 11, which is called LED. I want to turn it off, and that is low. So you see, I'm using high and low. High is 5 volts, low 0 volts. After it's been turned off, at the same time, wait for 1 second before you continue the cycle. So let me, good. So So this is how it will actually work. Now, let me explain something further here. The setup function is being required in order to set up the particular pin, what you want the pin to do. So this function will run only once. That is why it's called setup. It will execute only once. This setup function here will execute only once. But the loop function here you are seeing here, just like the name implies, a loop, something that continues running, continuous, that runs continuously. So it will, as long as the microcontroller is, whenever you power it, this program will keep on running the loop section continuously forever. So that is actually why a microcontroller works in real time, because they pick up the information, process it, still they run continuously. Okay, so we are good to go. Now for you to upload this program into the microcontroller, what you are going to do is to come up here where you see start simulation. Start simulation. You press the simulation. It's initializing. It's initializing. There is a problem. Okay. Sorry, it seems that your code has some errors. So let's see where the error comes from. So you can likely first this. Let's see where the error comes from, and we debug it. Okay. So to help you figure out where the error comes from. Okay. Right. I've seen the error. I made a mistake here in spelling digital right. Instead of digital right, I made a mistake. So you see, Tinkercad is very, very good. It helps you to figure out where you make mistake in your code and whenever there is an error. So I'll just come down here. Let me close this window, come down here to digital, spell it very fine. This is digital right. Good. You go back, come back to start simulation, click it again, it's initializing. Okay, good. We are good to go. So let me close this button. Close the dialog. Okay. So we close this window. Okay. So notice that the LED is blinking. Let me see. Turns off. It's off now. Just it's on now. After 1 second, it's on. It's on. It is off. On again. On again. Off. Have you seen it? On again. Okay. Now this is after every 1 second. The LED turns on. After 1 second, it turns off. 1 second, turns on. 1 second, turns off. So this is just a simple way to use microcontroller to control our LED. Good. If you want to change the color of your LED, just click on the LED. Click on the LED. Come down here. Go to the box. You can choose whatever color of LED you want, either blue, orange, yellow, green. Let's use a green LED. Let's use the green LED. Let's start simulating. Okay. Let me actually reduce the amount of time to half a second. Half a second, 500. Let's reduce it to half a second. 500. Good. So this is now half a second. Let's upload the code again. Go to start simulation and press start simulation, and it's initializing. Exactly. So notice again. It's off. Half a second. On again. Off. On again. Off. On again. Well, if you are following, please drop 222 in the chat box. Actually, if this project is fascinating, please drop 222 in the chat box. So very simple. We can now simulate a circuit. Thank you, Richard. So this is, thank you, Ekemini. So very simple. We can simulate a circuit. Any circuit in your mind that you want to build, just come to Tinkercad, design it, write a program, and upload it. You can tweak the code, whatever you want to do, you just tweak the code and you achieve your aim. Now, let's use this. Let me show you another thing that you can achieve in this code, and that is blinking fading an LED. Yeah, you can achieve it very simple, just to customize the program and it will work the way you want it to work. Let's do that. Let me show you how to use this same circuit here, and fed this LED. You want to fed an LED. Fading an LED means that it will turn on gradually, until it reaches its high maximum point. Then it starts fading away, turning off gradually, back to the original state. So it turns on, turns off, just fading. Now let's see how that can be achieved. Let me stop the simulation. With the same circuit, let's see how that can be achieved. So this is quite another one we want to do. It's called fading. Take note of the first circuit. This is blinking an LED. The code here is to blink an LED. Now, what if you want to fade this LED? So there are quite a few variables we would like to declare, and that is brightness. You know, fading an LED, the brightness increases gradually from 0 level to the highest point. The brightness decreases gradually, decreases gradually. So I would like to declare a variable called brightness. So this variable is called brightness. See, then for now, let's initialize that to 0, our brightness to 0, because our main point is the LED is off. Then we want to turn it on gradually. So brightness is 0. Now let's go declare another variable called fade amount. Fade amount, that is, what is the magnitude of fade you actually want? How fast do you want this to the fading to be achieved? The fade amount, I actually want to start with 5. I want to start with 5. That's my fade amount. You will come to see how appreciates the beauty of what I'm doing. That's my fade amount. Well, I'm going to clean all this code here. Then we are going to write another program to achieve this end. Now, we will not touch anything in the setup section because the setup section is good to go. We are still controlling pin number 11. But have this in mind. There is something I want you to notice here. Now, we use digital writes when we wanted to blink the LED on and off. We use digital writes and wanted to blink the LED on and off. But this time around, we are not using digital write. We are using another function called analog write. Now, Arduino pins, which you see here, if you look very closely, all these are D13, D12, D11, D10, D9, D8, D7, the D means digital. The D means digital. But what if you actually want to control the LED brightness? That is analog. Because whatever digital means high or low, 0 or 1, true or false, on or off, 0 volt or 5 volt. But at this time, we actually want to control the voltage, because if you want to fade an LED or decrease the brightness or increase the brightness, you need to vary the voltage supply to that LED. You need to vary the voltage supply. If it was 5 volts, 5 volts is the maximum voltage. If you want to decrease it, decrease the brightness, you bring it down to 4 volt, 3 volt, 2 volt. The more you increase the voltage, the more the brightness of the LED gets decreased. The more we decrease the voltage, the more the brightness of the LED gets decreased. So for that, for me to achieve this, if we look very closely in digital pin 11, 10, 9, 6, 5, 3. There is a tilde sign. There is a tilde sign. Let me zoom this further so that you see this tilde sign. There's a tilde sign in front of digital pin 3 here. There's a tilde sign in front of digital pin 5. Where my cursor is, my mouse cursor is. Yeah. There's a tilde sign. Please, are you people following me? Okay. There's a tilde sign in front of digital pin 6, digital pin 5.
Hello, everyone. If you can hear me loud and clear, can I see your hand? Just give me a thumbs up if you can hear me loud and clear. Okay, you can hear me loud and clear. All right. Okay. So I've just communicated with a tutor. He's having a little network issues from his environment, and then he's coming up very soon. Okay. So all right, he's back up. So just giving some seconds to set up his share screen.
I'm very sorry for the network loss. Very, very sorry.
We understand.
Okay, so let's go back to okay, good. We are back here. So now, as I was saying, if you notice closely the tilde sign in front of digital pin 11, digital pin 10, digital pin 9. So this sign means PWM. PWM sign, that is pulse width modulation sign. If you notice the writing there, you notice that the tilde sign is attached to the PWM here. So that means that we can actually vary this particular pin 5, pin 6, pin 3, pin 9, pin 10, pin 11. We can vary that particular pin. We can use analog write, vary the voltage from 5 volts to 3 volts to 4 volts to 3.3 volts. We can vary the voltage. So we are going to make good use of this pin. Good. Our LED is connected to digital pin 11, and that pin 11 is a pulse width modulation pin. So we can vary the width of the pulse, the digital pulse that is being sent. We can vary the width. So let's continue. Let me zoom back a second. So we can see exactly. Good. Let's move on. We are good to go. So the first thing to do is, okay, we want to turn on the LED with this particular brightness. So we are going to use the keyword analog brights. Analog brights. Remember when we were blinking the LED, we use the keyword digital right, because we're working with digital values. But in this case, we want to work with analog values. Analog values are values that varies. So numbers that vary 0, 1, 2, 3, 4, they are all variable numbers. Now, with this, we can actually vary the voltage level. of the width, the microcontroller, the voltage level. So we can vary the voltage level. Now, there's something I want you to note. Now, when we say high in digital write, high in analog means 255 because this is an 8-bit microcontroller we are working with. 8-bit microcontroller. 2 raised to power 8 is 256. 2 raised to power 8 is 256. So 0 to 255. So that means the highest value we can vary in which the weight is being set to is in analog value, the analog representation of 5 volts in this microcontroller is 255 because that is the highest value counting from 0. Well, if you are counting from 1, it is 256. But we are not counting from 1. Remember, counting in programming starts from 0. So counting from 0 down to the highest value is 255. So for this analog write, we specify the pin, and the pin is known as LED. That is the pin we want to write to. At the same time, we have to specify the brightness. So we just pass the brightness parameter, which you have already defined. You've defined the brightness to be 0. So in this case, it means that we are writing 0 to the pin 11. We are writing 0 to the pin 11. That is the instruction you are telling the microcontroller to do. You are telling the microcontroller to write 0 volts to pin number 11. That is the instruction here. LED means 11 because we use 11 to represent pin number 11. So brightness is 0. That is what is being stored. So we are telling the microcontroller, oh, write 0 to 0 means 0 volts. Write 0 volts to this pin. So in a sense, 0 volts means off at this case. So, but gradually, see, look at what will happen here. We are going to increase the brightness. We are going to increase the brightness by the fed amount. So I'm going to add the fed amount. I'm going to add the fed amount to this. I'm going to add the fed amount to this. So see, immediately adding the fed amount to the brightness. Now, remember this is a loop. It keeps on running continuously. Brightness initially is 0. Then I'm adding 5. Fed amount is 5. I'm adding 5 to this to the brightness. 0 plus 5 is 5. So the brightness in the left-hand side will be replaced with 5. When the program comes back again the second time, the brightness that it will pass to the analog write is not 0 again. It will now be 5 because I have incremented this value from 0 to 5. Now, what we are going to do, let me come up here so that we can actually see more space. Okay, good. What you are going to do is that since you have actually incremented the brightness, so you want to check with an if statement. So this is another control statement that we use in programming for controlling how our program flows. If statement. We want to check if the brightness, remember 0 means 0 volt, while 255 is the highest value that represents 5 volts. So we are checking if the brightness is less than or equals to 0. That's the first case. So look at the operator I'm using, less than. There is the less than operator and equal to. So this operator is less than or equal to. It's an instruction. Oh, check if brightness is less than or equal to 0. Or there is another sign I'm using there. That is, they call it pipe or vertical bar. You see the double vertical bar. The double vertical bar that represents or in C++ programming. But that's actually what we are using to control this microcontroller. The Arduino. Sorry. Okay, so we also check to make sure that the value, our brightness, is not more than 255. So we also check, is the brightness greater than or equals to 255? That's the next thing we will check. So notice how I use this logic. Programming is all about logic. Have that in mind. Programming is all about logic. Controlling your things in embedded system is all about logic. So first, you check your brightness. Is it less than 0 or equal to 0? Is it greater than or equal to 255? This is a boundary condition I'm using. Whenever the brightness is less than 0 or equal to 0, or it is greater than 255 or equal to 255, what should happen? That is the next question that will come to your mind. Now, notice that I've opened a body. That is the if statement body. Whatever I want should be in this body. So whenever this range has been the limit I set, whenever brightness has passed this limit, now I want to reset it. Brightness, how will I reset it? Okay, what I will just do is to invert the fed amount. Sorry. Remember, the fed amount was actually what we used to increase the value of the brightness. So at this time, I want to decrease the value of the brightness. I'm decreasing the value of the brightness. The brightness was 0 initially. Note, the brightness was 0 initially here, while fed amount was 5. So at this case, brightness is 0. 0 plus fed amount. Fed amount is 5. 0 plus 5. 0 plus 5 is 5. Brightness is now 5. So with that in mind, Arduino will now write 5. Coming back here, brightness will become 5. The program will keep on increasing from 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, because this condition is 5 less than or equals to 0? No, that is not true. 5 is greater than 0. Is 5 greater than or equals to 255? No, that is not true. So from 5 to 200 or 250, this condition will be false. This if statement will be false because 5 to 250, none of them is less than 0 and none of them is greater than 255. So with that in mind, what you are going to do whenever you reach this particular point, whenever this condition is true, you have to invert your fed amount. Invert your fed amount. It was positive initially. So now me attaching negatives to it, I'm attaching this negative to it. Notice the negative I'm attaching to it. This negative means that I'm inverting the fed amount from positive 5 to negative 5. So that will now be replaced in the memory where fed amount was being stored. Fed amount was stored as positive 5, but I will replace it with negative 5. So at this point, notice what will happen. Whenever this program returns back, since this is a loop, whenever it returns back to this line number 16, note line number 16, whenever it returns back to line number 16, this fed amount is now negative 5. It's not positive 5 again, it's now negative 5. Now brightness, at this point, brightness have increased from 0 to 255. 255 minus 5 is 250. 255 minus 5 is 250. Now, this program will keep on coming down here. This program will keep on coming down here. Okay, because you have inverted the fed amount, keeps on coming down here. Because fed, okay, sorry, it will not come in here. Look at the condition. Is brightness less than or equal to 0? Brightness is 255. It will not come in here. But the main point now is that you have inverted your fed amount to negative. Your fed amount is now negative. So whatever is the value for brightness will be subtracting. 5 will be subtracted from it. subtract 5 from 255 to start decreasing. 255, 245, 240, 235, 230, 225 down. But we actually want to see how this moves. How this moves. So what I'm going to do is to delay it a little. Let me just use 30 milliseconds. Not really much, but 30 milliseconds. Let's delay it a little so that you'll be able to see the fading amount, how it fades. So let's delay it a little. So let's bring this down. Okay, good. So I want to delay this by 30 milliseconds so that you see how the fading goes. Okay, so we are good to go. The LED will increase gradually, decrease gradually, increase gradually, decrease. So let's start simulation. If there is any problem, we are going to be notified. If there is no good, there is no problem. We are good to go. Well, let's see if this will actually fade. Okay. Let's look at good. Do you notice the fading? So it's very, very sharp. But just look at the LED. Look at the LED. It's fading, it's fading, it's fading, it's fading. It has first finished. Now it's increasing brightness. Start increasing, start increasing, start increasing. Are you seeing it very, very gradually? Whenever it reaches maximum point, that is 255, to start fading, 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 fading. Exactly, it has fed. That is 0. Start increasing again. So now look at what I'm going to do. Let me reduce the time. Let me stop simulation. Let me reduce this to 10 seconds. It will be very, very fast. The more you reduce the time, the more fast it becomes when it comes to fading. Okay, let's reduce this to 10 seconds and see how fast it should be. It's faster now. It's faster, it's faster, faster, faster. Very good. Let's change the color of the LED. Let's change the color of the LED. Now click on the LED. Let's change the color of the LED. Let's use white. White be okay. No. Let's use blue. Okay, let's see how blue works. Start simulation again. Just pay attention, look at the screen. Let's focus on this. Yeah, fading, increasing brightness gradually. Yes. Good. So this is exactly how we can fade an LED using Arduino code. Okay, we are good to go. Please, if you followed along while we do this practice session together, can you drop 3333 on the chat? Let's see that all of us were following. You followed along and you really enjoyed the session. Please, I want this to be interactive so that I'll know that we all are following. Okay, good. Richard Akpabio, thank you. This actually showed that you were following. Thank you, Mr. Nsisa. Good. So this is quite simple. And with this, we can simulate any circuit. So I would like you to do something, and that will be part of your project that you will do within the week. Don't worry, this will be sent to you in the Slack group. Okay, if you have any question, please, you are free to ask your question so that I'll see areas that you don't understand from what we have done so far. If you have any question, and ask your question. Any question? At this time, if you want to, if you delete or remove each component, you can just click the component and it will get highlighted. Come to the delete button here and delete it. And you can go back here, undo at the same time. undo, good. You undo what your changes. Okay. Any question so far?
Okay, thank you so much, Mr. Sondemba, for this wonderful class. We've all learned a lot in today's class. If I, Patrick, Ikemini, Richard, you guys are all welcome to this class. I guess you've learned a lot in today's class. Please, if you've not learned something in today's class, can you just give me a thumbs up if you've not learned something in today's class? Yeah, just give me a thumbs up. Oh, I'm not seeing anybody. All right, all right, all right, all right. That means we've learned a lot into this class. Okay, so here's going to be your task for the week. If I came in very late when the class must have gone very far, and then the videos are available on YouTube. So this very class was streamed live on YouTube. So when once the class is done, you can go to YouTube and then you'll find this video there. And at any point you have any question, feel free to reach out either to me or to the trainer, Mr. Sondemba, and we are always ready to answer your question and to help you solve it out. So I'll be dropping the tags. I'll be dropping tags 3, 4, 5, and 6 today, and the deadline for tax 3 is going to be tomorrow, 6 p.m. That's the end time for tax 3, and then from Wednesday, tax 4, and according to that. So one of the tasks you'll be doing is from this particular class, you're to mimic a traffic light using Tinkercad. So I don't know if that's, I know that's not a difficult one. It's just something we can easily do in some few minutes. So that's going to be the task. That's going to be our task. And I'm going to drop that on the channel. Please, I said the end time for the task 3 is tomorrow, 6 p.m. So tomorrow, 6 p.m., I'm going to close the submission link for task 3. And then Wednesday, 6 p.m., I'm going to close the submission link for task 4. And then I open the submission link for task 5 and task 6. That will be on Thursday and Friday. Okay? So with that, we'll all be in the same page with others. Okay? So is there any question for me or for the trainer? Okay, he said, please also help us drop the YouTube link again. Okay, definitely you're going to have the YouTube link on the Slack channel. So pay attention to the Slack channel. You're going to have the YouTube link there. I'll drop it there. So you can go ahead and look at all the things you've learned from the beginning of this training up to this time. Any other question? Okay. So in the absence of any other question, I would like to say a very big thank you to the trainer of today, Mr. Sondemba, for this wonderful class. And then we'll hope to have you again, same time, same session next week. And to all of you who joined to this class, I want to say a very big thank you to all of you. And then I'm going to see you next week. Thank you, everyone, and good evening.
Thank you, everyone. Have a wonderful evening.